Hello, and welcome to this demonstration of the AI capabilities included with Designcenter NX. In today's demonstration, we're going to use things like Copilot, command prediction, selection prediction, performance predictor, and even design space exploration to explore some of the capabilities included with NX. Let's go ahead now and take a look at some of the things we're going to do. Over here in the foil cutters, where we're going to do some of our analysis work. On the back side here, we're going to identify that we need to go ahead and blend off some of that raceway. And also up here in the mounting plate, we're going to notice here that we have some fasteners that are kind of close together. So we're going to need to make some design changes right here. So with all that being said, let's go ahead now and get started with our task for the day. The first thing we're going to do is we see along the right-hand side, we have our command predictor toolbar. And notice how that changes as we go along through the day. We start up Copilot to start our very first thing. What I want to do as a designer is I want to go ahead and clean up some of my display and take all the fasteners and just remove them from the display for now. So I ask Copilot, is there a way to select similar components? And there is, and it immediately starts up the command. It comes back when it gives me step-by-step instructions. You can see here I pick one of the fasteners near where I'm going to be working. It brings back a list of 5,000 parts, but I want maybe these first few fasteners up here on my list, and I'm going to go ahead and group all those together and take out the plate that doesn't fit. And you'll see I have over 1,900 fasteners. So what I'm going to do is I'm going to have NX select all those for me, and then using command prediction, I'm going to go ahead and hide all of those parts out of my assembly. Let's go ahead and see what parts we hid. So here's all those fasteners that were just selected and hid using a combination of select similar components and command prediction. The thing I want to do now is I want to put all these parts into a filter in my assembly. But I forgot how to create component filters. So again, I'm going to go to Copilot and ask it how I go ahead and create a component filter. It gives me the instructions, starts up the command, and I go ahead now and pick them all from the list, and I'll select everything on the screen. So now I have those 1,900 plus fasteners in a filter in my assembly navigator, and I'll just name it fasteners. So now I can quickly turn off and on the fasteners as I go ahead and do my design task for the day. So what I want to do now is command prediction again, and I want to turn everything back on to kind of show you what's going on here. You can see now that I have all my parts turned on. I'm going to zoom in on the area we're going to work, and we're going to go ahead and look at the fasteners. So I have 1,962 fasteners in this ad hoc filter, and I'm going to turn them off so I can continue my work and notice where the holes are and do other things. So what I need to do now is I need to start working in the context of an assembly on this plate. So I'm going to ask the Copilot how I can do that. And this time, instead of doing a command, it's going to point me to, with these little bubbles here with the numbers, to areas within the documentation and maybe go into more detail or something else with some more pictures. So in this one, it says, go ahead and do this. So if I look now over here, I can see that I have the system telling me to create a work part, pick the part, make it the work part, and when you're done, set it back to you can set back to the assembly. And that's kind of what I wanted to do. So Copilot gave me the answer I needed. I know I need to work on this plate, so I'm going to go ahead now, make this plate my work part, just like I was asking it to do. And with that, I'm going to edit a sketch. Once again, I'm not going to need Copilot for all, so I'll turn it off to clear up some of the room. And command prediction knew when I switch a part, sometimes I like to edit a sketch, so it goes right into the sketch task environment. I go ahead and I'm just going to make the plate a little bit narrower and update the plate. And you'll notice at first just the expressions update and the curves, but I want to update the plate that is driven by these curves and see where the holes are. So I'll go ahead and do that, finish it up. And then when we're done, I'll notice that the holes in the middle are kind of still in the way of the other mounting area when I went ahead and made this plate a little bit narrower. So what I want to do is I'm just going to move those two down for now. And again, command prediction's helping me out here. I'm going to tell it I want to go ahead and select holes. They could be holes or just geometry of holes. It doesn't need to be modeled as a hole. And I'm going to move those down a distance and go ahead and apply those updates. So when I do that now, I'll make sure everything else is still properly aligned, that all the holes in the other plates moved, all the screws, all the fasteners come back to where they need to be. So now that I have my design done, I'm going to go ahead and do that. So remember, I said to work on the displayed part on the assembly again. I'm going to turn back on my fasteners, and I notice all my holes and fasteners line up. Great. Our first task for the day is done, and we got some help. The next thing we want to do is we want to go down to this raceway track along the bottom here. And just for simplicity, I'm going to bring it over into a brand new window. And when we notice it all has little sharp edges on it. And there's a lot of edges here that I'm going to need to go ahead and create a blend on. So let's go ahead and see how AI can help us here with selection prediction. I'm going to go ahead set my value for my blends. I'm going to go ahead and pick one of the edges. And you notice I get this cyan bluish color, which is what it says, hey, you pick this one edge. Maybe you'd like all these edges too. It's not picking them. It's saying these are candidate edges. So I see as I zoom out, it picked quite a few of them. Didn't pick all the way to the end, but that's okay. I could either go in settings and adjust that, or I'm going to pick those, and I'm just going to scroll down to the other end, pick one more edge, and let it go ahead. And you'll see all the edges I need highlighted in that cyan or blue color. So I'm going to go ahead and select all those too for me now. And what you'll notice is with just 4 clicks of the mouse, I picked over 900 edges, which this now is a great productivity saver because now I was able to have it just go ahead and do that for me. They're all blended, and they're all blended now in the context of my assembly where it was, so I moved back to that. So now we need to go over to the foil cutter and start doing some analysis on it at the complete level, and then at the end we're going to do some other design space exploration with it. Maybe we can do something different. So we go ahead, we'll bring up the foil cutter by itself. And once we look at the foil cutter, you know it's a complete assembly. But in this case, we only really want to concentrate on 3 parts in the context of this assembly. So I'm going to go ahead and turn off all the other parts I don't need. The 3 parts I'm picking now are the parts we really need to use for our analysis study. But I'm a design engineer, so by being a design engineer, I'm not 100% familiar with doing design analysis workflows. So what I want to do is I'm going to go back and restart Copilot, and I'm going to ask Copilot how to help me out to do an analysis. I'm going to ask it, how do I add bodies? How do I add constraints? And how do I add loads? So again, now we're back with Copilot, and I'm going to ask Copilot, how do I add the bodies? Well, the first thing it says is you need to create a new analysis, and I don't even have that application running. So when I click it, it'll bring up a brand new analysis and start up the application of performance predictor for me. After I do that, I don't even need to go back because it has both commands there. So it says, take the bodies. I'm going to use the inherited material from the bodies. I'm going to go ahead and pick all these bodies, of which there's 24. Even though our components have multiple bodies. And you notice not only does it go ahead and pick all those materials from the bodies that it picked, it also builds all those face-to-face connections automatically for me, so I can now do my analysis. But before I do analysis, I have to set up a few other things. The first thing I have to set up is what constrains the movement in my analysis. So I'll ask it, how do I set up constraints? And it gives me a little bit of a help here. It says add the constraints, and it says you can do these types. Again, we talked about me being a design engineer, not an analysis engineer. So I'm asking, can you give me definitions for these types of constraints? And sure enough, it comes back and says, this is what kind of constraints and what they mean. I realize now I need a fixed constraint. So I'm going to go ahead and fix the 4 faces on the outer sides to kind of hold everything in place. And after I'm done with that, I'm going to need to apply some loads. And what we're going to do for loads is on these 2 bigger circular holes on the middle parts, we're going to go ahead and create some loads on there. Again, I'm using Copilot to say, how do you apply loads? What are the definitions of loads? In case I forgot, I can ask it. It's without going out of the application somewhere else where I can maybe assign that information. So the first thing I want to do is on one of them, I just want to do it along a vector back here, along this mounting area. I'm going to create one force there, and I'm going to create a force on the front. And what you'll notice in Performance Predictor is the status goes from at the top, now it's a red exclamation point. It's going to go to a blue calculator to saying it's doing the analysis. I could keep modeling and doing stuff as that's working, but what I really want to do is I want to wait for this one to finish up and see what it's doing before I continue to model. So I can continue to model. There's other things I can do with Performance Predictor. If I don't want it to continuously solve, I can delay it a little bit. I make quite a few, maybe some more major changes, but you'll notice now that the analysis is in progress. So let's go ahead now and give that a little bit of time to finish up. And what we'll notice now is we can look at the displacement, the deflection, and the safety factors that came back. Even though I'm only a designer, I do understand enough about deflection and stress and stuff. So I'm going to go ahead and look at some of those. I'm just going to clean up the display here a little bit, move the stuff closer to where we can see it. And we'll notice right now, we're looking at displacement. Okay, that's what our scale on the side is. But we can also just switch very easily from displacement into stress. And with any of these turned on, we can also animate it anytime we want to kind of see how those things are bending or stressing or even displacing. So I go ahead and play that movie, kind of evaluate that. Now I want to go ahead and look back at my displacement. So I understand all that. A nice thing here within this is not only that front part that I also had some loads on, it's kind of all blue now. So what I want to do is I just want to turn on one body, just the body that was more towards the front, which is the single hole, and I get a new scale It doesn't point to the maximum stress, but I can kind of see what the stress and displacement here now are. And what I can do then is I can go ahead and turn on just the second body. You notice how the scaling automatically updates to the bodies I have turned on. So what I want to do right now is I want to turn on all the bodies. And now what I want to do is I want to set up just a single analysis on the middle part. And we're going to do something what's called design space exploration, where we're going to have it kind of solve a problem for us. So to do that, let's skip ahead, and we already have some stuff done now. We have a different analysis set up on the same parts. But what I'm going to do is I'm going to go ahead now, like I talked about before, I'm going to move that plate that's up on the top in the middle there, and I'm going to move that plate over a little bit because all our stress is concentrated on the right-hand side of the part. And we know if we move something that's stiffening it towards it, the stress and the deflection will go down. I mean, that's just engineering, but we can kind of set that up as one move, and we'll notice it resolves, and I get a new displacement value. But what if I want to find out what the best value for something like that is? I went through all the trouble to set up this analysis and do stuff. So what I'm going to do right now is I'm going to start a design validation. And what I'm going to do during that design validation is I have a variable for that moving value of that thing. So I'm going to say I want to minimize the displacement at the corner where it is. And then I'm going to say you being NX, you can go ahead and move that plate back and forth wherever you think it's properly. And where AI comes into play here is with our HEEDS solver. HEEDS is a solver that helps quickly get to answers faster and better than most things. It uses AI to kind of evaluate where it's going, where it's been, and where should it go next. So once I get everything set up, like I said, at first I said I want to minimize the stress, and then in this case I'm only using one variable, but I could do multiple variables. But in the interest of simplicity here, so you understand what we're doing about, I give it a min and a max that it can move to what positions. How do I want it to increment in between? It'll use some number in between, and then I have that set up, and I'll go ahead and run this performance predictor. I'll just do 10 runs. But while this is running, what you'll notice that that piece moves across the part back and forth. And then now again, it's going ahead and doing things. At one point, you may see it just kind of disappear and come back, and we'll talk about that at the end. It also, because of the values I picked, it can run that part off of the part, which will be a non-valid solution because it doesn't have everything still tied together. So once it's all done, we'll go ahead and take a look at all the values we have. I have it set up so when it's done, it will end up in the position of where it is at that point in time after these 10 runs. We can see it now. But I can go to the results now. And in the results, you'll notice I have some red ones which say I cannot complete that. This is the best one's the green one. So I'm just going to apply that design to my parts here. That'll minimize my displacement, and I can move on, and the performance predictor solves one more time, and I'm all done. So I want to thank you for your time. What did we see here? We saw how you can become more productive by using some of the AI tools to eliminate redundant tasks, such as selection prediction. We also found out that how you can use Copilot to help you figure out how to do things you may not do a lot or don't remember how to do or are new to you. And we've also used some of the advanced tools within design space exploration to help me find the best design for my part based on the parameters I set up and did it. I want to thank you for watching this demo and have a great day.